Hey everyone, welcome to my talk on AI security and code. My name is Liran. I'm a developer advocate at Snyk and I love joining you here on this talk, just talking about security, AI, LLMs, ChatGPT, GitHub Copilot, all of those kind of things. I am known as the guy with the Yoda hat, I guess. I am a developer advocate at Snyk, like I said, and I'm really on a mission to help developers build securely. So I do this through many things around the Node project, JavaScript security, writing some content on best practices to build applications with secure code, with security kind of built in. I'm on the ecosystem on various projects, whether they are OWASP or other related to more specific to Node and JavaScript. So you can find me on all of those. And with that said, let's get started. So what do you think is the most dangerous line of code you've seen in the world? I've got this one here for you to share. This looks like a loop, maybe an endless loop, maybe not, maybe an infinite loop, maybe not. I don't know. Take a look at that one more time, and that's it. So think about it for a second as you see it. This is one of the most very obscure code you probably have seen, right? It's kind of curious, like what's going on there. Why is something wrong with this? This looks like a very generic loop making this and that iterations. But specifically, if you run this code on a system that does not have the enough bit capacity, so if this was running on on something like a 16-bit system, right, on an embedded system or something like that, it would not have the enough integer specific range to go through the 100,000 cap here, which is the top limit. We actually go from minus 32k to plus 32k, which is the integer range, back and forth. And that makes it an infinite loop. That makes it this kind of like endless loop that we talked about, maybe potentially it is. So it really depends what context you run this code in. And this is where things get interesting, right? Like you could even have as regular code as this becoming potentially dangerous and devastating to a system, just depending on the context where it is running on. And this is going to be a very nuanced decision making, where we will use code in different aspects from these different places suggested to us, whether they are from ChatGPT or GitHub Copilot or other kind of tools that we may be using, but not entirely understanding the exact potential devastating consequences they might have. And we'll talk more about the security aspects of those. So at times, I think you would be able to kind of like relate to this. Your vulnerable line of code is probably your first security regret, because you do not want to, code and build insecure applications, and you want to build software quality with high standards and all of those things. And take a look at another piece of code, like let's say this one. So here's a piece of code from a Node.js an Express middleware, right? Like there's like a request, a response comes in and out. There's like a next middleware. A user that find seems to be something that maybe we will be using as maybe a database query to find the username and password. Looks like maybe it's doing some kind of a login request, potentially. But if you look at it and you're thinking, is something wrong here? Is it missing sanitization? Is it missing validation? All of that is probably true, but can you actually tell what is the vulnerability, the security vulnerability that is of the issue here? So of course, this is kind of like where it's at, right? The username and the password, those are values that we use in the code that are brought to us from the user input. This is not something that we control. Request by the username and request by the password are coming in from users. Users are deciding what values they will take. And then we use them and to query the database. So I want to show you the code of like, why is that potentially problematic? If you haven't seen that before, that's okay. Let me pull off my screen here. So we've got this system, which is a login system based on a very, very simple Express application, nothing fancy here, username and password, going to the login route. And if you look at the code here that handles this, the login handler that handles that all of that login business logic, it's doing this, validator is email. So there's actually is some validation even going in, flowing in, checking whether the username is a valid email address. And then, similar to what you've seen before, there's like a user that find for the username and the password. it matches them. If something is fine, it redirects and all of those kind of things. And let me pull off my my screen here for the CLI, and let's play with this a little bit. So I've got this kind of handy ready here. I'm basically echoing a JSON username and password, which are, this is actually the seems to be the legitimate password for logging in. And I'm passing this to like the HTTP CLI, telling it this is a JSON request that should be made. And we've seen before, it goes to the /login page. If we run it, we see the request going in, a post request here, super secret password, amazing. 32 found, and then redirecting to /admin. So the login was successful. And if I would change this again and change this to something like 1234, doesn't exist. So we get 401 unauthorized. Makes sense? What if I tried something that's not really the password, but is also meaning something else? Let's say that what I'll add here is not really a string as the value of my password, but actually an object with a key greater than, which tells the database maybe, match all of those strings that are greater than, greater than nothing. So that's basically matching, I think, everything. And if we send this over, we now get to see the exact request being the value, which is now not a string, that's an object passed from request body password to the password to the user that finds MongoDB query to the database itself, and it succeeded because it is actually a NoSQL injection. As we can see here, I've got like I said, I'm from Snyk, and I've got the Snyk extension here on the IDE telling me, flagging it like a nice linter that helps me and says, there's like a NoSQL injection happening here because there's nothing sanitized and you're like passing values straight in. And this is not a regular SQL injection, which if you had tried to use some inputs, some malicious user inputs, like let's say the minus to ignore the rest of the code, or close with a single quote and do an or 1 = 1 or something like that, wouldn't really make sense here because you would still have a string value at the end of it. But because we understood how this query code is actually not written in a secure way, we have exploited that fact to our advantage, and we're able to create a NoSQL injection attack payload that allowed us to bypass this whole, if it's a login, the login, but this could have been a different kind of query which we would have bypassed as well. So back to the story here. I kind of showed you here why this was a vulnerability that was happening, and this is an issue that was happening because many times when you have this kind of like codes used by different applications, you may not entirely know what's the actual impact there, but it has an actual impact that goes straight up from everything from your code to the actual application dependencies that you might use. In fact, there's this application called RocketChat, based on open source. It's based on an open source project that of the same name, actually used a similar pattern of using like a user.find1 in their code to be able to then grasp data from the database. And to do that, it was actually using some insecure code to all of this. Oh, there we go. Now I got it. I lost screen for a second here. So here is it. Here it is. This is RocketChat. 12 million users over 150 countries. If you scroll further, this is the line of code. So it actually implements a get password policy with this users that find one, and you can see the params token being passed in as the exact same way that we have done with the user that find one with providing the password. Here it's taking it from the request as is to the value of one of those keys. This is, in our case, this is services, that password, that reset, that token. And if I provide that with the similar type of hack, the exploitation payload of an object, well, now I significantly change the entire aspect of what this would be, the query would be. So kind of like, we're just starting off, so don't sweat it out yet. talking about secure coding and those kind of practices, and even just before that, right? Like we understand that your vulnerable line of code potentially is your first security regret because you do not want to ship insecure applications, right? But then what is your first line of code? Is that the code that you write, or maybe that's the code that you're taking from somewhere else, right? Let's talk about it for a second. So a bunch of us developers who write code visit this website called Stack Overflow, at least did before ChatGPT, right? And when we did that, we did it to be able to understand what's going on. Maybe we would be copy pasting stuff into our code. These days, it's, as easy, I would say, as even going further and saying, well, you know what? What about open source libraries? Should I use them? Maybe I should just ask ChatGPT directly. I'll pass some logic that I need to be doing and get a response back and use that. So we've got this landscape of sources of insecure code that potentially could flow into our applications. Those could be NPM packages that we did not test whether they are secure or not. We maybe do not even look at the code to review it or something like that. We take it from source from Stack Overflow. We take it from ChatGPT directly because we ask it some questions and wait, maybe that code is okay, I can use it. It's an LLM, right? A large language model. There's like a lot of coder, probably is okay. I don't know. Let's see in a minute. Maybe even from GitHub Copilot. And you've kind of like got into this. I'm going to post that meme now and show you that you kind of like got into this state, I think, where you could relate, which is like, should I really just code myself? Write the code myself, that is. Or just use ChatGPT or something else to build that for me. And that's like a tough question right now because all of this great tooling for developers exists, and a fraction of the time or cost for you to actually use it. But that said, there are some risks even beyond just security that we should be aware of. They're called, one of them is called AI hallucinations. And if you look at it for a second, it kind of, if you think about it, here are some examples, right? I've asked ChatGPT, to have this simple math equation solved. Of course, the answer there is completely incorrect, but it had no issues telling me that it was incorrect. Someone told me in a prior talk I was showing this that I need to tell the LLM that this is a math equation. I need to like prompt it and hint it. So I should use like this equals sign at the end of it, as if that would change something, but it didn't. So this is like a real ChatGPT thing, and it hallucinated the answer. It is confident, 100% confident that this is the answer, which we know it isn't. It's not really running a calculation for this in behind the scenes. Another example related to text, not even math, right? Like generate a text without the letter E in it. Obviously, in that whole paragraph, there are many E's repeating themselves here, right? So it hallucinates something it thinks is a very confident correct answer when it's not. And this really just joins a bunch of AI security risks that we should be aware of, right? I've kind of looked down, researched on a bunch of areas, what would be kind of like distilling AI security risk, and Microsoft Securing the Future of AI from last year, that's a paper they put out to the public, had actually cited some interesting, very clear messages. Like this is one of them, right? The fact that these machine learning models are learning based on data that it's public, right? It becomes public. It's potentially even you can influence that data in a sense, right? Because if, I don't know, GitHub Copilot learns on all of the repositories that exist on GitHub, well, what if some of that code is actually bad code, bad for performance, bad for security, bad for maintainability, bad for different reasons, right? It's not all of these data sets are learning on optimal code and optimal data sets. And that is, that's part of maybe the beauty of it, which, shows us creativity, but also where, bad things could happen as well at the output of those LLMs. Another aspect, which is most of the times, even, people building those AI systems, it feels like a black box, right? Like there's like so many hidden layers of this, of aspects going in this, which, you don't really understand even how it actually works. And there's like the whole temperature aspect, if you've used ChatGPT, for example, before, like the playground or the API, you could tell it how much to be creative versus to be deterministic. And those things are still very abstract to us to understand. And so LLM generated code, or insecure code at the end of it, is kind of like a risk we should really be attuned to. Let me give you a practical example. I asked ChatGPT a while back, help me solve a backlog story I needed to work on. So, started off this session like that. Of course, it got a bit bossy and with an attitude that morning, but I didn't let it implement my mood here. I was like, no, we need to do it. So implement a post endpoint for file upload, using the Fastify web application framework. I've specified the exact route API/uploads I wanted to use. And we kind of like got this conversation going. It replied, with almost functional code. Not everything here was okay. I noticed it was hallucinating a bit around some aspects, asked it to correct it, and it did. And so this is one example. I don't know where it got this upload file.mv from, but I told it needs to fix it. And then, of course, once this done, this is already a pretty good functional code just to upload files, which is, by the way, pretty cool. Like, I enjoy the fact that I could actually do that with a copy paste, right? Like, who would not do a copy paste at this point? So I wanted to do this, but then I remembered if I do that, everything can burn down because there is a security issue there. Now, let me take you to the actual code. Maybe you'll relate to what I was saying. So if we go over here, not this one, but I think we do have, is it this other thing? I think I have the Fastify thing here somewhere. Is it, app2, I think this is the one. Yep, so here it is. So this is basically a copy paste from, also got it over here. So this is the actual chat. You could go and see it. I've corrected some stuff, and then at the end of it, it implemented. I basically can copy the code here, which is basically what I did prior to this presentation, and copied it here. So you can see the actual code here. It's functional. It's working. If I would run it, it would literally work. Maybe you already understand what is going on and why this code is insecure. If you don't, that is why it's really crucial that we have those AI security tools to help us understand what is going on, what is potentially wrong. The thing is, when you're working with files, the security issue here is potentially that file could be, it depends do you serve the file? Do you use like a download or an upload? If it's an upload route, like in our case, it means that we could provide the content of a file to be written somewhere on, wherever this is being saved, maybe on disk. And so maybe if I am doing a path join like here from an uploads directory, in my file name is not really the file name that you would expect, like, let's say, picture.jpg, maybe it's //picture.jpg, and you get the idea, right? And so I can then overwrite like outside of the scope of the private directory I was supposedly given or expected to save files there to somewhere else, which is what we're basically seeing here. The Snyk extension I'm using here has told me there's like a path traversal vulnerability. Unsanitized input, which is file name is an unsanitized input, it's coming from the user, is appended and flows into a specific create write stream, which is a sensitive OS API that I can use to write files to the ecosystem. So you could see exactly what is wrong with this code. And if I did not have this I don't know, in my case, a VS Code extension with Snyk that looks at the code, runs it, understands it. It's not just a grep to find, with a regular expression what is going on. It understands the flow of the code, and it is able to then pinpoint and show you exactly what is going on here. So given that, right, we understand, I think, one aspect of this of this code, and these are the lines which is introducing the vulnerability and where it flows into the actual problem. And I've shown you the code here. Let's go with another experiment. Experiment number 2. What do you think of this code? This is a bunch of experiments that are taken from someone's blog on exact specific issues with AI hallucinations. but related to security and related to code. And so I thought it would be interesting to share those, to show you exactly how it can be wrong, not just with JavaScript or, or specific aspects of it. But here is one example. Like the person asked ChatGPT, what do you think of this code? Could I use this? I don't know, look at this code. There's like a file name there, temp, OWASP, join. It looks like a path reversal initially, but everything here is hard-coded. There's nothing coming in from like a user input, right? The file name .txt is literally hard-coded there. But there's an actual issue here. And what happened is it asked the ChatGPT, right? Like, could I use this? And it answered with different ways of like, maybe what you should be using, the way that the code works. At the end of it, it just said, this code can be used if your goal is to create a temporary directory with, all of this file name specified, blah, blah, blah. So didn't really understand, ChatGPT model here didn't really understand anything from what was actually potentially dangerous to alert you about this. Like if you would ask it, is it insecure? It wouldn't understand. Here's the insecurity. This is the actual security expertise context that is a lot of the time missing from those kind of models that, are just spitting out text, not understanding the actual nuances of the context they are being executed on. And the problem there is that temp file that get temp here is essentially almost always going to be the same exact value, because that is being looked at by Python to the environment variable called temp directory. So what we're having here is a vulnerability often known as time of check, time of use. And there's like a lot of, I've mentioned here a bunch of CVE classifications, those kind of like enumerations of the type of vulnerability that actually is. So that's like, insecure temporary file, creation of a temporary file in directory with context, with incorrect permissions, and different kind of issues that code has that are potentially a problem. And this experiment continues, right? We go on and say, let's try a different kind of code. And that person asked ChatGPT once more, how is this code? Should I use this? And, I'll give you a second look at, what this Python code is doing. Process execution, checking the output of, providing, shell equals true, providing a command that would probably spawn a process. ChatGPT answered, once more with a lot of information about this. But, in conclusion, at the end of it, if you see, if you're running this code on a Unix-like system, legitimate use case for pinging a server, this code should work. What it's missing from all of that, generous output that it explained to us what is going on here is the fact that there's like a very, very obvious security vulnerability here. If I'm able to provide, you see that there's like a % string, which is my server, to provide you the IP, and I can provide you an IP, which is not really a string of an IP address, but rather a string of a command, like 8.8.8.8, a semicolon, which terminates one command on a Unix and starts a new command, deletes all of the file system, and you could see what is happening if that command would be injected as the input for that Python function that might be implemented, by some system. And this is the classic command injection example, which flows in. And ChatGPT, even if you had copied over the code like we did and asked it, which is, by the way, not a really smart idea to do, because you may be violating a lot of copyright and intellectual property issues with the code that you write in the company, this would still not help you. Experiment number 4. What if we would ask ChatGPT to help us, find a library that we want to use, like find an NPM dependency maybe for Node. In this case, it's a library in Go to implement secure session cookies. Sounds great. It answered back, a very popular, well-regarded library, blah, 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 is Gorilla/Sessions. I don't know this, but it sounds interesting. Maybe I would try and use it. If you would open, and it, explains more about this, but specifically popular and well-regarded library. If you'd open the GitHub repository for it, you would see that actually I don't know if this is the entire project or not, but at that point in time, at this point, the repository, the source code repository for this Go package has been deemed archived and not very maintained at that point. Not really a good suggestion for ChatGPT to suggest to us, and I'm pretty sure if you would have just done that without even looking at first the repository, the downloads, the maintenance, the tests it has, all of those kind of things, you would just copy and start using it. Later on, finding out that it's not really maintained, the repository is archived, that wouldn't be something you'd want to do, and you would have chosen yourself. So you can see these hallucinations are coming up and biting us. well, let's take that and actually do that experiment with Node, which is actually an interesting aspect. So next up is this experiment, which says, how do you integrate with arangodb in Node.js? Please return the packages to install. And it asked it, there's like a bunch of iterations on this. They're all very hallucinated. But here's a specific other conversation on this, which is like, okay, then it asked it, write a code that uses arangodb, suggest 3 packages to use. It suggested arango.js, arangodb, and I don't know, this namespace arangodb slash velocipack, whatever. Now, the thing is, that number 2 package, arangodb, if you would go ahead and install it, you would find it doesn't exist. So this company at, Vulkan.io, what they did and wrote in this blog is they understood that AI hallucinating for you NPM packages that do not exist mean that they could do that experiment before someone else does it. Like, how do I use, give me the Lodash library to install? If you have some typos, if it hallucinated something for you, the ChatGPT response that doesn't exist, they could go create that package, publish it as a malicious package that if you install it would devastate your local development machine or whatever. And you would be at risk. So all of those AI hallucinations, when you kind of couple them with the security aspects of what could go wrong, kind of starting to understand it's not really just about the code. It's about the suggestions that those ChatGPT and LLM are making, the GitHub Copilot and stuff like that. And when we go to GitHub Copilot, I actually want to show you this more in detail, more hands-on of like what exactly would be happening there. So this is our close to last experiment here. Let's go back to this. This was a nice ChatGPT tour of what could go wrong. Let's go back to your vulnerable line of code here is your first security regret. And now the person suggesting the code is GitHub Copilot, not just us. So what does it look like? Well, I'm going to show you an application, a React application, front-end one that uses this. It has to make use of a dangerous API that you wouldn't want to use regularly because it couldn't expose you to cross-site scripting requests. And it's called dangerously set inner HTML, but you sometimes need to use it. This is sometimes an escape hatch that you have to use because you cannot provide React components down the tree all the time. You must sometimes provide it with the actual HTML, the raw HTML tags that need to be written to the DOM, to the page. And so here is an example. And you also I imagine that developers using this understand that they need, when they use dangerously set inner HTML, which is, like I said, sometimes a legitimate use case, you have to add your own security controls because then React stops protecting you and you need to start protecting yourself. To do that, you probably want to use something that allows you to escape this, potential bad code. So you would do something like, escape HTML, a function that takes dangerous characters like HTML elements the left triangle and the right triangle and all of those things that will actually introduce raw new HTML elements, and you want to escape them. So let's do that experiment and see what happens. I'm gonna go and see if my IDE is able to work here. What we need is this part of the code. So what I'm showing you here is my React code base on the left, and it uses some data from the database. I'll show you this in a second, but essentially this is the part which shows you that you're using dangerously set inner HTML. Now, Snyk already found this issue for me here that says, hey, this is a cross-site scripting. It even shows you maybe has automation, actually auto-fix to fix that problem. But for now, we don't really want to fix it. I want to show you how suggestions made by generative AI tools like GitHub Copilot could potentially be still dangerous. So we know we need to clean this up, right? We know we need to clean this up. Now the data that is getting auto screenshot description is from this to the right, which is this database JSON is actually taken over, is used over an API request. So the front end is making an API request to a server that serves this as a database. So it's not really a database, but it's as close as we can to make things, not too complicated for the demo here. So let's go to what we need to do is open a new page here. Is it? Yeah, there we go. Let me rearrange the screen here for a sec, so it's going to be a lot easier for us to see what's going on. So we have lorem ipsum as part of the outer screenshot description. This is the React page that is being shown to us there. You see it shows you this screenshot, and if I go over here, it has this lorem ipsum. I can change this to hello Node.js people. Reload the page. There we go. Okay, so this is live reload, this is live, this is everything is like live coding and happening here. Now I can make this a bit bigger if we need to. It's probably not really needed, but we can. So let's do it. And now we're asking ourselves what could really go wrong here? Like what's the dangerously setting on HTML that could actually blow up? So what if we had, now that we know that this data is being added to this HTML element, we can, as malicious actors, exploit the fact that this is being done. So you can see it being added here, outer screenshot description, as the alt text, as part of this whole image tag that needs to be closed here. So I can actually close it myself as the input. It's an interesting GitHub Copilot suggestion there. And then open a new one. And you can see it even suggested for me an actual, I don't know if I actually need this last one, probably don't really need that because it's already closed here. Let's try that. But what we're doing here is we're passing a new image tag, HTML tag, like a valid element to the page. Sources exo doesn't really exist, and then if there's an error, it will say there's an error, alert 1. Yeah, let's try that. See what happens. Refresh the page. And there you have it. We have basically now been able to hack the application in a sense where we exploited a cross-site scripting vulnerability on the page, meaning this alert 1, when I refresh the page, you could see our new input coming on here. And we're now able to run JavaScript on the page, the JavaScript that we control as user input. Remember, this is something, the lorem ipsum, the screenshot description here is something that's coming from the database, right? From user input, they're saving it, in some other screen, and then it shows up in this screen, right? So this is something you do not want happening. And one way to mitigate this, like we said, is to escape these HTML strings. So what I would want to do here is, I'll call it, I don't know, escape HTML made up function, which we'll create in a second. And I want to be able to escape this function, right? To escape the outer description text. So whatever is coming out here, it will then be replaced by what's called HTML entities, less than, and all of those kind of things. So this wouldn't really work. Of course, I have no idea how to write this escape HTML function. So I'm gonna push the code here, function escape HTML, and it obviously takes a string, and I'll let GitHub Copilot maybe suggest it for me, which is exactly what it did right now. So that looks okay. Return a string, replace, kind of like what we were thinking. The same, I'll save it. You see it auto formatted it, less than, and greater than. Yep, that seems to be legitimate. That seems to be a good use case to locate potentially dangerous strings and fix them. And if I'll save this just in case I forgot, and reload the page. Let's see what happens. Okay, so first off, no alert popping up, no alert box, so no JavaScript was able to be added. And you could see here what React would usually do. By the way, the same thing it would actually internally do for element, for input that you give it, is to use HTML entities, like encode the text that is going out. It's called output encoding in the security terminology. It actually encoded this string. So you could see that these are not anymore real text characters that terminate an existing HTML element, the image, and introducing a new one, but these are representations of the actual strings of a triangle in different locations on the page. And this seems to be helpful, right? Like I could show you there, if you try to do function, clear cross-site scripting, maybe ask it to do that. Did a bunch of regular expression in different ways. So you could see it suggesting different ways, and maybe that is something we should have used, maybe not. But you could see it doing suggesting different ways. The problem that's actually going on here is the context of applying this prevention measure is incorrect. What do I mean by that? This is a fine way of a payload to exploit the attack. But if you understand what is going on there, this is the value that goes into the on-error handler, the attribute, the alt attribute itself. So that does not have the exact same context and mitigation as HTML elements. Attributes and elements work in different ways, and they are governed by different controls within the DOM itself. So what if I did something like onload alert? What's happening now if I save it, and I still have my escape HTML function here working and protecting me, or I thought it was, maybe I just, I tried it, even, went ahead to like create a test for it, see that no alert was, popped up on the page and sent this to production. Now what's happening, there are no dangerous characters here to fix, right? It tries to match all of those characters, but none of them exist in this kind of input. And if I go back to this page and I refresh it, I still get the alert 1 popped up. And you could see I basically were able to escape the alt attribute and create an onload new attribute for the image. This is an actual attribute to the page itself, right? To this element itself, existing as a top citizen to the page. And this is why this is actually an incorrect way of, putting your trust or your confidence sometimes on LLMs. Because even when you're using an escape function like this, it may not be the correct escape function, or it may not apply in the correct context of where you should be using it, which is goes further to show you how using a LLM and GitHub Copilot and ChatGPT is great. I use it myself. I'm not saying not using it, but understanding that it is not a security tool, and it is not it does not provide you with a security answers for how you should be writing code that is production ready. So if we go back to our slides here, like I can show you different examples of how it tried to provide autocomplete. I tried escape cross-site scripting like this, which is similar to what we've seen. It even escape XSS. I prompted it and it provided me with this autocomplete, which was you could say it's kind of like halfway there, but even that wouldn't have helped me to mitigate the exploit I actually showed you with the attribute itself. And this also didn't work. So you could see how all of those are, failing. So I want to leave you off with, in this talk, with some key takeaways. One of them, if you're into reading a bit of more best practices and how to have security controls, specifically around LLMs, OWASP developed, OWASP is a security organization, voluntary organization for the application security. And they have this top 10 cheat sheet for LLMs. We've got this as a, you'll have the slides afterwards, but we've got this as an actual, obviously it's bigger than this. It's more of a document, so it's a long one, but we've got this like a PDF, like a cheat sheet that you could actually use, and summarizes all of those specific aspects. You could see how we talked a lot about, prompt injection here, insecure output handling, which is kind of like what we talked about now. Training data poisoning, number 3 here on the slides, which is what I showed you to begin with, one of those AI risks that Microsoft had actually called out in their paper from last year. So this is a good, I think that you'd enjoy going through this one. Another thing I really enjoy is gamification. So having fun while learning is, I enjoy that. So I want to show you, if you haven't seen that before, there's this company called Liran, and they have this challenge called Gandalf. If you'll just Google Liran Gandalf or Gandalf Security or something like that, you'll probably find them. It's an AI character. Basically, this Gandalf here, this character here, holds a password, and you need to find it. And all you can do is ask it questions and try to convince it to give you the password. And there are different levels. Some of them are like really easy, like the getting going one. And after you pass a few, it gets a bit harder to kind of like extract the information. And it teaches you, it gives you that context of how interacting with an LLM, the prompt injection, everything, when you build upon LLMs, not just using those tools like ChatGPT or GitHub Copilot in your IDE, it shows you how building AI security tools is also very, very hard to do, because you could actually exploit that. And lastly, I'll leave you off with, if you're going to use, and I know you will use those generative AI tools like, GitHub Copilot and ChatGPT, please do it responsibly. I obviously suggest something like Snyk. You could easily install it. It's free to get started, and, just create an account for like an API token thing. But the whole workflow is seamless if you install it from the IDE, and it just runs in the background for you every time you do a command save to save your code. It will read the code, understand it, provide you with advice how to fix it, or your code, your dependencies. It's pretty wild to see when it actually works on your code. So this is me. Thank you for coming and enjoying my talk. I hope this was great. If you have any questions, I'm on Twitter, I'm on GitHub. Reach out, wherever you want. We'd love to talk to you about all of those things. So awesome. Enjoy the rest of the conference, and everyone else's talks here are pretty amazing as well. So have fun, and I'll see you later. Stay secure.
This was actually amazing talk. We actually thank you, Liran, for this talk. It was really very helpful for us. So, guys, you may leave comments and questions to Liran in our Discord chat. Liran will answer those questions. And now we have a break, and we'll meet at the next talk from Matteo Collina. Not end of production is a lie. So we'll see in 20 minutes.